All right, here we go. I want you to turn to page 735 in your book and follow along with me. This is new territory for all of us, but we can get through this. I know we can. Okay, we are going to, in this lesson, we are going to describe triangles, three-sided polygons, okay? Our question is, how can you use sides and angles to help you describe triangles? We know what a triangle looks like, but there are different types of triangles, and we are going to describe them. Our objective, we will model, describe, and compare triangles based on the number of sides that have equal length and the type of angles they have. So basically, we're looking at the triangles, looking at their sides, and then the angles, the space in between the two rays. Okay, this first page is wonderful if you have straws at home. Many of us do not have straws, plastic straws at home. If you do, go ahead and do this activity. But I'm going to go ahead and skip this, go to the next page, because I know some of us do not have the straws at home. So right now, we are going to go to the different ways to describe. Let me get my pen set up. There we go. Good. All right. So let's look at these triangles. You will see. It's not going. Okay. There's our pen. Let me try it again. I'll even do that. There we go. Okay. We have A, B, C, D, and E. They all look different, don't they? But they all have one thing in common. They're three-sided polygons. Well, it's like fruit. You have fruit, okay? But there are bananas that are a fruit. We have grapes, and then we have apples. And then there might be different kinds of apples. That's what we're going to do. We're going to classify, we're going to group all of these triangles, okay? The first way we're going to group is by looking at their sides. And it says we're looking at the sides that have equal length. Okay, so look at A right here. All those sides have the same length. Okay, they're all congruent sides. They're all the same size, same shape. That is called an equilateral. I know it doesn't show it up there, but that's an equilateral triangle. Okay, that's an equilateral, equal as in the same. Okay, over here we have triangles that have two sides that are the same length. Okay, so we have this side and this side that's the same length. We have this side and this side that are the same length. Those are called isosceles triangles, when two sides are the same length. Isosceles triangles. Okay, now over here we have C and we have D. Okay, none of those sides are the same. They are not equal. None of these sides are equal on any of them. So those are called scalene. I know your book doesn't say that, but like those angles, obtuse, acute, and right, I want you to know these terms: equilateral, isosceles, and scalene. Okay, so let's look here. If I have, and then another way to describe them is by their angle that the two rays connect. Right there, that space in between those two rays, if you look on C, look at that angle that the two rays are creating, okay? It is larger than a right angle, so it's an obtuse angle. It's an obtuse angle, an obtuse triangle. Now look at these triangles. All those angles are less than 90 degrees. This is an acute triangle. Now you're saying, but Mrs. Keith, this has two acute triangles. Why isn't this an acute triangle? Well, to be an obtuse triangle, at least one of the angles have to be obtuse, okay? In an acute triangle, None of the angles can be right or obtuse. They all have to be acute to be classified as an acute triangle. Okay, now look at B and D. Right there, we see the little boxes in the corner. And if we put a piece of paper in there, we'll see that a piece of paper fits right in there. That is a 90-degree angle. That is called a right triangle. Okay? So by looking at the angle, we have an obtuse triangle, we have an acute triangle, and we have a right. Just like with an obtuse, only one angle in this triangle has to be right to be classified as a right triangle. Okay? All right, let's go on. Write the number of sides of equal length the triangle appears to have. Well, I see 2. Okay? So it has 2 sides of equal length. It is an isosceles. Isosceles, isosceles, isosceles. Say that 3 or 4 times together to yourself. Get that in your brain. Isosceles, isosceles. Okay? All right, here we go. So triangle blank has one right angle. Well, it kind of cheats for you. It gives that little square there in the corner. So triangle F has one right angle. G and H do not, okay? Triangle blank has one angle greater than a right angle. Well, right here, that's my obtuse angle, so that's H. Angle blank has 3 angles less than a right angle, so it's 1, 2, 3. All 3 of those, okay? So this is a right triangle. This is an equilateral. No, I'm sorry, acute triangle, and this is an obtuse triangle. Okay? All right, there we go. On your own, use the triangles for 5 and 7, right? K, L, and M. Okay, triangle blank has one right angle. Okay, so let's look at this. There's only one that has a right angle right here. So triangle M has one right angle and appears to have two sides of equal length. Okay, so it's a right triangle and a right isosceles. Okay, triangle blank has 3 angles less than a right angle. Okay, so which one have 3 angles less than a right angle? That would be K. And it appears to have how many sides of equal length? 3. Okay, so it is an acute triangle that's equilateral. Okay, oops, sorry, I'm trying to go down. There, oh, this is Keith, what's going on? There we go, sorry. Triangle blank has one angle greater than a right angle. There's your obtuse angle right there, your obtuse triangle. So it's triangle L has one angle greater than a right angle and appears to have blank sides of equal length. I don't see any sides that are equal. 0 sides of equal length. So it's a right scalene, okay? Remember, scalene, they have 0 sides, that's scalene. Okay, 3 sides of equal length is equilateral. And 2 sides of equal length is an isosceles. Isosceles. Okay. All right, let's go to the next page. Okay, Martin said a triangle can have 2 sides that are parallel. Does his statement make sense? Now let's think about this. On a triangle, think of all your triangles. Look at these two triangles. Is there any way that a triangle can have parallel lines? You say, no. There is no way, because all of the lines intersect, okay? All three lines, intersect. Okay? So there is no way that they can be. Okay. Nice try, Martin. Okay? We'll give him kudos for trying. Okay, compare triangles R and S. How are they alike? How are they different? Well, first thing I see, they're three-sided shapes. They're three-sided. And look at the angles. They are acute angles. Okay. Now, how are they different? Okay. Well, their sides. Angle R, I'm going to put angle R here. I'm going to do that. I'm doing this for angle R. That's to represent, sorry, but angle A, angle R, that right there tells me it's an angle. Angle R, the sides are equal. Okay, that means it's an equilateral triangle. Equilateral. Sorry, my fingers are too fat to put all of this on here. Okay, and then with S, angle S, okay, the sides, there's only two sides that are equal. So there's only two sides that are the same. Two sides equal. What do we call that? We call that an isosceles. Okay, good job. All right, I am not going to make you do 10 because we do not have a ruler, but we're going to go on down to 11. Write the name of each triangle where it belongs in the table. Some triangles might belong in both parts of the table. Some triangles might not belong in either part. Okay, so let's go to, has one right angle. Well, I see N. Okay, I see P. I see L. I see R. Okay, that makes it easy. Those little boxes help, don't they? Okay, has at least two sides of equal length, which means it could have three sides, couldn't it? But it has to have at least two. Well, I see J does. J is an equilateral triangle. Oh, I'd say P. Some are really tricky. P does. K does not. Nope. I don't think N does. Q does. I see Q. They have three that are same. I'd say R does. Okay. I'd say O does. I think that's about it. All of these other ones look like they're scalenes. Okay. I know it can be tricky sometimes to tell, but you try your best. All right. I want you to try to do 12.7. Okay. Yes, you can do question 6. Okay. I want you to do 12.7 for me. Okay. I will make another video that gives you the answers, or actually I will show you the answers that the book puts on there so you don't have to listen to me anymore, okay? But I want you to do it first and then check the answers from the book, okay? All right, now I'm going to assign the little rabbit videos. Make sure when you do your rabbit videos, please, please, please click on the elaborate and the share and shows. Make sure that you're doing all the share and shows. Click on those so I can see that you understand the work. Okay, thank you.